Hello everyone, welcome to CSC Core Concepts in the series of data structures. Let us now understand a non-linear type of a data structure, that is trees. In my earlier videos, I have discussed about the linear type of a data structure, namely arrays, stacks, queues and linked lists. So what makes them a linear data structure is that the storage is in a sequential order. Now here you can see that all data need not be stored in a sequential order. Sometimes you need to represent certain data in a hierarchical order, and for that we require a hierarchical representation in the form of trees. Let's say you want to show the directory listings, that the root directory and then the parent directory, and then you have the child directories, then you have files inside them. So in case you want to represent such a structure, you can use a tree. Or if you want to show a family tree, that is who are the grandparents, parents and their siblings. So these are some of the real life examples of trees. Now if you consider this tree, you can see that there are two child nodes of the tree of the node 5. 5 is called as a node and the edges are what they connect two nodes. They are called as the edges, right? So here 5 is one of the node. Now it has two children, that is 3 and 7. 3 again has two children, that is 2 and 4. 7 has only one child, that is 6. This is how it is being represented. So since 3 or 7, you can say they have some children, they are called as the parent node. There can be one child, there can be two child, there can be n number of childs. Okay. So anyway, if they have at least one child, they are called as the parent node, and the child, the nodes to whom they are parent, they are called as the child node. And if you realize this, in this complete tree, there is a subtree, that is 3, 2 and 4. That is a part of that tree. It is again in itself a tree. So that is called as a subtree. Now the nodes which do not have further children, they are called as the leaf nodes. Okay, they are not having any more children. And now if two nodes are originating from the same parent, they are called as the siblings. So in this case, 2 and 4 are siblings of each other. Now the levels of the tree, the root node is at the 0th level. Okay, then comes your level 1. So in this case 3 and 7 belong to level 1 and level 2 is your 2, 4 and 6. If again further 2, 4 or either of 2, 4 or 6 have child nodes, they will come under your level 3 and so on. So based on this, let us discuss about the height and depth of a tree. Now many students get confused about the height and depth. They feel that both are same, but it is not so. Okay, so to understand the height and depth of a tree, let us consider this tree where each node has a maximum of at the most 2 children, right? So what is the depth? The depth is the number of edges from node to the tree's root node. Okay. So now if you consider any node, okay, let's say B you are considering. What is the distance from B to its root node? Who is the root node? Root node in this tree is A. So the distance from any node to its root node is the depth. So hence, what is the depth of a root node? The root node itself has depth 0 because root node to root node distance is 0. Right. So in case of a depth, the root node depth is always 0. If we are considering the height, then the number of edges on the longest path from node to leaf, right? If you want to consider the height of any node, so you find out that what is the distance between that node to the leaf node. So now if you are considering the leaf node only, let's say you are considering node D. D itself is a leaf node. So what will be the distance of this leaf node to the leaf node? That is 0. So two things you should remember very properly. So it will be very clear to you that the depth is the number of edges to the root node and height is the number of edges to the leaf node. So always the depth of the root node is 0 and the height of the child node is always 0. Okay. So let us see the depth and height of each of these nodes in this figure. So if I am considering node A, as I know it is a root node, so its depth is 0. Now what is the distance from A to its leaf node? Now who is its last leaf node? Its last leaf node is G. Okay, so from A to C, C to F, F to G. So how many nodes you have to cross in order to reach till the leaf node G? 3. C, F and G. So the height of A is 3. Understood? So the distance from root node, that node, any node from wherever to the leaf node is your height. Now let's consider the depth and height of B. So depth is 1. Why? Because B is at one step distance from node A. Right? A is the root node. So depth is 1. And how many leaf node? What is the distance from B to its leaf node? Its leaf node is B. So B or D or E. So from the height is again 1. For C, the depth is 1, fine, because it is at 1 unit distance from the root node. But what is the height here? 2, because it has its leaf node is what? G. So 2 nodes distance is its height. Now for D. Now D's height is 2 because the distance from D to the root node is 2. Okay. Now height is 0. Why? D is already a leaf node. There are no any nodes after D. So the height is 0. Similarly for E also, the depth is 2, fine, but the height is 0. Now if you consider the node F, depth is 2. It is at a 2 unit distance from the root node. Okay, but its height is 1 because it has one more child, that is G. And in this case, G is a leaf node, so its height is 0 and the depth is 3 because it is at a distance of 3 units from the root node. So I hope it is clear that what is the difference between the depth and the height of a tree. Another concept about tree is the in degree and the out degree of a tree. So for that, to understand that, consider this tree. Okay, so the in degree is the number of direct parents or incoming edges. Okay, each node has exactly one parent, right? But root node will have no parents. Understood? Root node does not have any parent. Fine. Now out degree is the number of direct children or outgoing edges. Okay, so in degree is how many edges are coming towards it. That is in degree. And out degree is how many edges are going outside. So each node can have 0 children. Okay, out degree can be 0 if I have no more children like the leaf nodes, or it can have more children like it can have one child, it can have two child, it can have n number of children. So for considering the root node A, its in degree is 0 because it is not, there is no incoming edge. A is only outgoing. Okay, A has two edges, adjacent edges, B and C both are what? Outgoing. So it does not have any incoming edge. So A is 0 incoming, but out degree how many? 2 because it has two children. Fine. Now consider B. Incoming is 1 because it is inherited from one parent, right? A. So incoming towards B is 1, A, that is coming from A, and out degree is 2 because it has two children, D and E. Okay. Now similarly for C, in degree is 1 because it has only one parent. Okay. Always the in degree of the root node will be 0 because it has no parents, right? So in degree of C is 1 and out degree is 0 because C has no children. D. For node T, in degree is 1 because B is the only parent from where it is coming from. But the out degree is 0 because it has no more child nodes. For E also, in degree is 1, that is one parent from B, and out degree is 0. Okay, because it has no children. So let us understand the concept of the types of trees. Okay, so what are the types of tree? One is a binary tree. Binary tree means every parent can have 0, 1 or 2 child nodes. When I am saying bi means what? 2. Maximum there will be only 2 children. Okay, that is a binary tree. 0, 1 or 2. Then complete binary tree. Complete binary tree means what? When every node has exactly two children. Right, you can see the difference between the first figure, that is a binary tree, and the second figure, that is the complete binary tree. Okay, so it has exactly two children. and M-ary tree if there can be more than two children, right? So here you can see for the root node has three children, then each of its children has again three child. So it is an M-ary tree. Now sometimes the tree is going only in the left hand direction. A to B, B to D, right? So this type of a tree is called as a left skew tree because the nodes are only getting attached to the left hand side. And similarly there can be nodes which are attaching only on the right hand side of the tree. They are called as the right skewed trees. So, for this video we will stop here, and in my next video we are going to see how we can represent any expression using a tree form, and we are going to discuss about binary search trees in detail. How do they work and the traversal of the trees. There are three ways by which we can traverse, that is the in-order traversal, pre-order traversal and the post-order traversal. So this we are going to discuss in my upcoming video. So please stay tuned for more such informative videos, and don't forget to like, share and subscribe to CSE Core Concepts. Thank you.